Okay, last week we looked at naming a number of different organic molecules. In particular, we looked at alkanes, and we can see an example of an alkane here. We've got an alkane with 2 carbons in, and so if you remember our prefixes from last time, we had meth for 1 carbon, eth for 2, prop for 3, but for 4, pent for 5, hex for 6, hept for 7, oct for 8. So here, when we were naming this compound, we said, look, it's just got 2 carbons in the chain, and hence this was eth, and because it was an alkane, only with single bonds, ended ane. So we've got here an example of ethane. The thing is that the alkane molecules are quite unreactive. Okay, they can burn them, they react with oxygen, but other than that they are pretty unreactive molecules. If we look at another molecule though, here we could draw out an alkene, which we also mentioned last week, and here we've got an alkene with 3 carbons in. And so we say here 3 carbons, prop, and we've got a double bond here, which is what makes it an alkene. So this molecule would be propene. If you like, prop 1ene, double bonds on the first carbon. Really, it has to be on the first carbon here if we've only got 3 carbons in the molecule. So we can just call that propene. Now this double bond is really what makes this molecule a lot more reactive than the alkane above. And we call this part of the molecule that is responsible for all of its characteristic chemical reactions, we call that a functional group. So here we've got the alkene functional group, which is what gives rise to the particular chemistry of the alkene molecules. We looked at naming alkenes last time. What we want to do this week is to introduce some other functional groups and some other types of organic molecules. So let's begin to do that now. The first type of molecule we're going to introduce here are the alcohols. Now an alcohol group simply contains an OH functional group. So let's look at an example of an alcohol. Let's start by looking at, for example, an alcohol with 3 carbons in it. There we go. A simple alcohol molecule. We could, of course, equally draw that by using a skeletal formula if we didn't want to bother drawing all the carbons and hydrogens in. What we would have here is a zigzag, 1, 2, 3 points on, and then an OH group. So each point of the zigzag is a carbon atom. We don't need to draw the hydrogens on. We know that carbon always forms 4 bonds. If the bond isn't shown, it is to a hydrogen. So how are we going to name this molecule? Well, you can see here whether we look at the display formula or whether we look at the skeletal formula. In both cases we've got 3 carbons in the chain here, and we've got the alcohol group, the OH group, actually on the first carbon. So we would number this from the right hand side in order that we put the functional group here on the lowest numbered carbon. So we would call this, because it's got 3 carbons in, it would be prop, and then to name an alcohol it's propan 1-ol. Now the OL here at the end indicates that we have an alcohol, and the 1 here indicates that the alcohol group, that's the OH group, is actually on the first carbon atom. Okay? Let's look at another example. So this time, let's have the alcohol group there. again, can we name this molecule? We've got 1, 2, 3 carbons in a continuous chain. So once again, it's going to be prop, and we've got 1, 2, 3 carbons. This time our alcohol group is on the second carbon instead of the first one. So here we would have propan 2-ol. Simple as that. What about if we had more carbons in our alcohol? So we could have this molecule. How are we going to name that? Well, again, number the carbon chain. Number it from the side that's going to put the alcohol group onto the lowest numbered carbon. 1, 2, 3, 4, 5, 6. So what we would have here is hexane, we've got 1, 2, 3, 4, 5, 6 carbons, and our alcohol group here, you can see, is on the third one. What we have this time is a branched alcohol molecule. You can see the alcohol group here, this time on the right of the molecule. So what we're going to do again is we're going to number the carbon chain so as to put this alcohol group on the lowest numbered carbon. So I will number it here from the right. 1, 2, 3, 4 carbons. So because it's going to be a 4 carbon chain, it will be boot, and then 1-ol to indicate an alcohol group on the first carbon. And then of course we've got this methyl group here. Try and ring that methyl group there, which of course is on the second carbon, so it will have to be 2-methyl butan 1-ol. Now then, the next type of organic molecule we're going to look at are the aldehydes. Now an aldehyde, instead of having an OH group, it will have a CO group, we'll call a carbonyl group. And for the aldehyde, that carbonyl group will be located at the end of the carbon chain. So let's look at a simple example of an aldehyde. Here we'll have a 2 carbon long aldehyde. So what are we going to call this one? Well, we've got 2 carbons in the chain, and we've got here the carbonyl group at the end of the molecule. So because it's 2 carbons, it would be F, and instead of ending OL as it would for an alcohol, if it's an aldehyde, that's with a double bond to oxygen, it ends AL. So there we have F and Al. No need to put a number in because we always know that if it's an aldehyde, the carbonyl group has to be at the end of the carbon chain. Have another example. Well, let's do it actually using a skeletal formula. So, for example, we could have that molecule. How many carbons have we got here? We've got 1, 2, 3, 4, 5. So what we would have here, 5 carbons, is pent. We've got pentanal. And that is an aldehyde. So what have we got so far? We've got the alkanes. We've got the alkenes, which is where we've got a carbon-carbon double bond. We've got an alcohol, which has got an OH group. And we've now looked at aldehydes, which is where we have a carbon double bonded to an oxygen atom at the end of the carbon chain. The next one we're going to look at are the ketones. Very, very similar to the aldehydes, but instead of the carbonyl group being located at the end of the carbon chain, this time we're going to find it somewhere in the middle of the carbon chain. So here, let's have a look at that molecule. Not drawing it very well, but there we go. So here we've got a ketone, because this time, instead of being on one of the end carbons, our carbonyl group here is located in the middle carbon here, on the second one in this case. We've got 3 carbons in the chain, so it's going to be prop for 3 carbons, propan, and then if it's a ketone, it's going to end O-N-E, propanone. O-N-E at the end of the molecule indicates we've got a ketone. If it ended Al, propanal, that would indicate that the double bond was on to the oxygen was on the end carbon. What about this molecule? Okay, so what we've got here is a carbon chain which has got 1, 2, 3, 4, 5 carbons. Let's number them. 1, 2, 3, 4, 5. Now then, what are we going to call this one? Well, it's a 5 carbon chain, and therefore it's going to be pent indicating 5 carbons, and we've got here a ketone group. Now, 2 possibilities here. If we've got 5 carbons, of course, and we've got a ketone, it could be a ketone with the double bond to oxygen on the second carbon. It could also be on the third carbon. So what we're going to do is we're going to call this one pentan 2-one, which just indicates here that our ketone group is on the second carbon rather than the third one, just to make sure that that structure there is clear. So pentan 2-one here. We didn't need to do that with propanone, because if it was going to be a ketone with 3 carbons, it had got to be on the second carbon in order to be a ketone, otherwise it would be an aldehyde if it was on one of the other carbons. But with pentan 2-one, we need to indicate here that our ketone group is on the second carbon rather than the third one, which it could have been. Okay. So in this unit, the next type of organic molecule that we're going to meet is going to be carboxylic acids. Now, carboxylic acid will contain COOH group like that. So let's have a look at a carboxylic acid. Let's have a look at let's have a look at a simple one. Here we've got a molecule. It's a carboxylic acid because we can see here at the end of the molecule we've got this group. We've got a carbon which has a double bond to an oxygen and a single bond to an OH group, and together we call that a carboxylic acid. Now, to name this molecule, again, just look for how many carbons we've got in the carbon chains. We've got 1, 2 carbons here together, so it's going to be eth, ethan, and if it's going to be a carboxylic acid, benzoic acid. Ethanoic acid, carboxylic acid with 2 carbons in the chain. Of course, I could have drawn that with a skeletal formula, which would have seemed to look like that. 1, 2 carbons, that second carbon, and double bond to an oxygen and an OH group. Again, perhaps let's try another one. How many carbons? Well, we've got 1, 2, 3, 4, 5, 6, 7. Carboxylic acid. Recognise the carboxylic acid group at the end of the molecule. If it's 7, it's going to be heptanoic acid. And there we are. Halogenoalkanes are simply an organic molecule where one of the hydrogens has been replaced with a halogen group. Now, halogen is group 7 in the periodic table, so we're looking at chlorine, bromine, iodine. So let's have a look at an example. Now the halogenoalkanes are simply named using a prefix. So just like when we were doing alkanes, we've got 2 carbons here, so it's going to be eth, ethane, and then to name the halogenoalkane we use a prefix, so we would call this one chloroethane. If you want, you can call it 1-chloroethane, but really wherever we put the chlorine in this molecule, it's going to have to be on the first carbon. If we put the chlorine over on this one, we will just start naming from this side of the carbon chain. Let's have a look at another example. Let's have a look at this molecule. What are we going to call this one? Again, first thing, how many carbons have we got in the chain? Let's start numbering from the carbon that the bromine is attached to, which is that one. That's 1, 2, 3, 4. So what we have here, 1 bromine, and we've got 4 carbons. So that's 1 bromobutane. Yeah. Now if it was an iodine instead of a bromine, we would call it iodobutane rather than bromobutane. So there you go. Chloro if it's chlorine, bromo if it's bromine, iodo if it's iodine. Right, let's have a look at another halogenoalkane here. Let's have a look at this molecule. Now what we have here is a branched halogenoalkane. It's actually a bromoalkane. Now if I number the carbon chain, 1, 2, 3, 4, 5. Now we have here 2 groups. We've got a bromine group here on the end of the molecule on the first carbon. We've also got this branching methyl group on the second carbon of the chain. Now when we name a molecule here with 2 prefixes, we put them in alphabetical order. So bromine, B for bromine, is going to become before the M of methyl group, so that's the one we will name first. So we name the bromine number from the end of the molecule with the bromine on, and we've got a 5 carbon chain, so what we're going to have here is 1 bromo, 2 methyl, and then because we have 1, 2, 3, 4, 5 carbons, that will be pentane. So 2 prefixes here, 1 for the bromo group, 1 for the bromine, 1 for the methyl group, B before M, so that becomes alphabetically first, and there we go, 1 bromo, 2 methyl, pentane. And the final class of organic molecule that we're going to meet at this stage are the amines. So let's have a look at an amine. here we are. So an amine is a molecule that contains an NH2 group, as we can see here at the end of the molecule. Now the simple amines are actually very easy to name because you basically just name them amine, and then in front you put the name of the alkyl group. Now remember, if it's a 1 carbon it's methyl, 2 carbons is ethyl, and 3 is propyl. So we just actually name it for the alkyl group here as a prefix. You just name the alkyl group that's actually connected to the amine group. So we would call this ethyl amine. 3 carbons in there, propyl amine, 1 carbon, methyl amine, and so on. So basically, what organic molecules do we need to name at this stage? Well, we need the alkanes, we need to name the alkenes, the alcohols, carboxylic acids, the aldehydes and ketones, halogenoalkanes, and the amines. An alkane, carbon and hydrogen atoms only, just single bonds. Alkene is going to have a double bond somewhere on that carbon chain. The alcohol group is where we've got the OH group. Carboxylic acid is where we've got a COOH somewhere in the molecule. The aldehydes and the ketones have both got a CO group somewhere in the molecule, but on the end of the carbon chain it's an aldehyde, in the middle if it's a ketone. The halogenoalkane is going to have a halogen, that's chlorine, bromine, iodine usually somewhere on the molecule, and an amine, that's going to have an NH2 group. And there we are.